Hello and welcome back to another exciting episode of Engineering with Chris. Today we're looking at AI cameras, a little bit about what they are, what they look like, how they work, what the output looks like, and a little bit about where they're going to be useful. So right here I have two 770 style reverse cameras. Here is a traditional regular camera, and then here is an AI enhanced camera. They look virtually identical. They have the same kind of form factor to them. We have started to see AI cameras start to penetrate the market in 2023. I think that 2024 will be a big year, and we'll start to see tons of these AI cameras on the market. So let's do a deep dive and demystify them a little bit about what they work and what they look like. So here is a simple block diagram of a traditional camera that we have right now. So, and then here I'll move this over as an example here. So as the light enters the front of the camera, the lens will collect that light and add it down to a detector. The detector will take that information, turn it into this digital video signal, and will output that to a digital to analog signal processor. This chipset will take that digital signal, turn it into an analog signal, and output the video and audio information outgoing this way. Sometimes, for example, this is a 5-pin camera. Sometimes that extra 5th pin can be used for data information or to trigger something on the camera, such as the IR. In this case, we'll just kind of ignore that for now. And then power and ground will flow into the camera. There's going to be some kind of DC to DC converter, and typically we will see something like 5 volts, 3.3 volts, 1.8 volts, and these voltage rails will help power all the chipsets on the camera. So that's a little bit about how a regular camera works. How an AI camera is different is that it adds a little chipset right there. So obviously this is not to scale, but just to give you an idea. So as the lens collects the information on the detector, and the detector builds a signal and outputs it, instead of going right into the digital to analog signal processor, it instead first goes into an AI imaging chipset. That AI imaging chipset will look at the camera image frame by frame, and if it detects an object that looks like a person, it will highlight it with a little box, person or a vehicle. And then it will output that information to the digital to analog signal processor, and it will go out to the monitor, business as usual. So what does that look like a little bit? Let's look at a video example. So on the video that I'm going to show you, I have installed a reverse camera. Instead of on the rear, I've installed it on the mirror looking forward. I did this so that I could run tons of objects through the detection zone, and we'll see if the camera highlights them or not. So what does that look like? Let's find out. All right, here on our video, you can see we have our reverse skylines in the center. Of course, if it was a side blind zone detector camera, this detection zone would look a little bit different. But so now we'll go ahead and hit play. So now, as the system is moving through and it highlights an object, it sees an object, it will highlight it with a little yellow box. We'll also notice that we got a little vehicle indicator icon up at the top indicating that it has spotted an object, it's a vehicle. So now we'll move through this one. You can see now, theoretically, there is no limit to the number of vehicles it could detect in frame. Because it's analyzing it, semi-frame by frame, it uses this information then, it can highlight as much as it sees. So we'll move through here and we'll see some various objects. For example, here is a school bus. It's able to detect it. Here is a second school bus behind it. It's able to detect that. It's able to detect a blue sedan even with a partial image, so that's very powerful. So move right here, and then as I come up to this curve, we will see some new vehicles. So there's a service body truck. It's able to select that. Red sedan. It was able to highlight this vehicle with only a partial image as the vehicle is first coming into frame. As the image box is inside the detection zone. So for example, right now the yellow box is in the green and yellow zone, and so it highlights both of those. And then of course when you were reversing, the object would be coming straight at you, and so this would detect a little bit better, but as they're passing to the side, that's kind of what that looks like. So let's go ahead and skip ahead a little bit further. Okay, so as we're moving down this avenue of vehicles, it's able to detect multiple vehicles, even if they're kind of stacked on top of each other, such as this one is now. We'll move ahead a little bit further towards the end. Okay, so we're going to be watching this beverage truck right here. So the system has highlighted the truck. See the door open. Driver is stepping out. Got it. So now the system is highlighting the pedestrian as well as the vehicle at the same time. And you'll notice in the upper left, we see the pedestrian icon as well as a vehicle icon. Grab both of them. So that's a quick overview about what the image looks like coming out of the camera. Where this type of system will be useful is as the driver is backing up, of course, you're going to be using your mirrors, but then this system will be able to help alert a driver that there is something back behind there. More so than a simple sensor system or a simple camera system, this will help provide some audio alert that, I see a person, I better alert the driver. I see a vehicle right behind me, I better alert somebody. So it's just an extra layer of information to provide to the driver, just more information. So hopefully, we will see this technology propagate more and more, and it will just be a safer experience overall to have this type of technology integrated into your system. So that is a quick crash course overview about what AI cameras are, a little bit about how they work, and where they will be useful in the future.